What type of isotope is represented by this combination of subatomic particles? Isotope A, B, C, D, or E? The subatomic particles are protons, electrons, and neutrons, all of which have a certain mass and charge. So we have 8 protons, 9 neutrons, and 9 electrons, but how does that help us discover the elements of interest? Well, when comparing the two elements side by side, we see that they each have a different number in their elemental box called the atomic number. For fluorine, it's 7, and for oxygen, it's 8. The great news is that atomic number is also the exact same thing as proton number, so we're going to have 7 protons and 8 protons respectively. Therefore, we can eliminate choices A and C, because if our isotope has 8 protons, it must also be the element of oxygen. So let's start building our isotope. We have the chemical symbol as the base and some sort of number on both the top left and top right. It turns out that the top left is mass number and the top right is charge. Why don't we start with mass number? Among the subatomic particles, both protons and neutrons each have 1 atomic mass unit, and an electron's mass is treated as 0 because it's so small. That means that the mass of an element is just the sum of the protons and neutrons, because each is exactly 1 AMU. And since our oxygen isotope of interest has 8 protons and 9 neutrons, the total mass is going to be 17 atomic mass units. So our mass number is 17. Notice how we leave off the AMU when we add it to the isotopic notation, and we'll also reject answer choice C. Now we have 2 options left, and charge is the deciding factor, but what exactly is charge, and how do we find it for our isotope of interest? Charge of an element is going to be protons minus electrons. We ignore neutrons because they don't contribute any charge. 8 protons minus 9 electrons means that this isotope of interest has a -1 charge. And charge goes in the top right corner, so the correct isotopic notation for this combination of subatomic particles is B. To ensure you understand the ins and outs of correctly writing and dissecting isotopes, be sure to check out the video on your screen and in the description.